Welcome to a video on multiplying polynomials. My name is Mr. Bell, and before we get actually started, I want to go over the skill that you need to be able to do this particular lesson. And from our exponent unit, when you have something like 5x to the fourth power times 2x to the third power, let's talk about real quick what happens when you have a situation like this. Remember that you're going to take the coefficients of your terms, you're going to multiply them, since that's our operation that it's asking us to do. Well, 5 times 2 is 10. Also recall that when you multiply like bases, you simply add their exponents. So in the case where we have x to the fourth times x to the third, don't multiply those exponents. The rule is we're going to add those exponents to get 7. So 5x to the fourth times 2x to the third power is actually 10x to the seventh. This example asks us to find the product. And remember, product means multiplication. So we're going to take this 3x to the squared, and we're going to multiply or distribute it to all the terms on the inside of this parentheses. So to begin with, 3x to the second power times x to the third power. Remember, there's an understood coefficient of 1. 3 times 1 is 3. X squared times x to the third is x to the fifth. Remember that we add the exponents. Continuing to distribute, 3x to the second power times 2x squared would be 6x to the fourth. 3x to the second power times 5x would be 15x to the third. Remember that we have 2 here and an understood 1x that they don't always write with this x. And then 3x to the second times negative 9, which is negative 27x to the second power. That's going to give me my answer, which appears to be answer choice letter B. This example asks us to find the product, which means to multiply. This time we're multiplying two binomials, and let's begin. So I'm going to take this first term in my left binomial, and I'm going to distribute it to both terms in the right polynomial. So in this case, 3x times 4x is 12x squared. 3x times 2 is 6x. Okay. Next thing I'm going to do is take my second term in my left polynomial, which happens to be a 5. I'm going to distribute it to both terms in the right polynomial. 5 times 4x is 20x, and 5 times 2 is 10. And then as my last step, I'm going to combine my like terms to get 12x to the second plus 26x plus 10. And let's see which answer choice that looks like. That looks like answer choice letter D. I do want to talk about another method for multiplying binomials that you may have heard about or will hear about in the future. And it involves an acronym called FOIL. First, outer, inner, last. Okay. It's the same steps that we just did. They just use the letters of FOIL to help you remember which ones. For instance, the F stands for first. That's where you multiply the first two numbers together, which we did that. The O stands for outer, which means you multiply the outer two terms, 3x times 2, which we did that as our second step. The I stands for inner, which means multiply your inner two terms. 5 times 4x is 20x, which we did it in our method also. And the L stands for last, where you would multiply the last two terms together. 5 times 2 is 10, which is the same thing that we got from our distribution method. This example asks us to find the product, which means to multiply. So again, I'm going to take my first term, which is 7a of my left polynomial. I'm going to distribute it to both terms in the right polynomial. 7a times 2a is 14a squared. 7a times negative 3 is negative 21a. And don't forget, you have to come back and do the same thing with the second term in the first polynomial. 4 times the 2a is a positive 8a. 4 times the negative 3 is a negative 12. Combine your two like terms in the middle to simplify. In this case, we're left with 14a squared minus 13a minus 12. And then we'll look for that as our answer choice. It looks like answer choice C is our correct answer. In this example, we're asked to find the product again of two binomials, but you may notice this one has larger numbers, but it's the same concept that we've been working on before. To multiply, we're going to take our first term, which is a 12x, distribute it to both terms in the right polynomial. Well, 12 times 14 is 168. X times x is x to the second power. 12x times negative 15 will give us a result of negative 180x. And now we got to come back and distribute the negative 13 to both parts. Well, negative 13 times 14x is negative 182x. And then negative 13 times negative 15 would give me a positive 195. My next step would be to combine my like terms in the middle. Bring down the 168x squared. Negative 180x minus 182x is negative 362x. And then bring down the plus 195. That looks like answer choice B, as in boy. This example asks us to find the product. We're multiplying two binomials. Let's take our 10x and we're going to distribute it to both terms in the right polynomial. Well, 10x times 10x is 100x squared. 10x times 5 is 50x. We'll take our negative 5 here, distribute it to both terms. Negative 5 times 10x is negative 50x. And negative 5 times positive 5 is negative 25. In this case, when we combine like terms, if you notice, our middle two terms cancel, and we're left with just 100x squared minus 25, which is answer choice A. And you'll see this pattern again in the future, where it's called the difference of squares in a factoring situation. And you'll notice the pattern that we have 10x minus 5 and 10x plus 5. In those cases, your inner and your outer terms that you combine cancel, and your result does not have a middle term. In this example, we're asked to find the product. In this case, we're taking the product of a binomial and a trinomial. So in this case, we're going to have a lot more steps and a lot more terms to combine, but we can do it. Let's get started. Take this 3x from the left polynomial. We're going to distribute it to all three terms in the right one. So first off, I get 6x to the third power. 3x times 5x is 15x squared. And 3x times 7 is 21x. A little trick that I do sometimes when I distribute the second term, 4 times 2x squared, since it's 8x squared, I line it up with its like term. Just makes it a little easier for me to remember to combine them in the end. 4 times 5x is 20x. 4 times 7 is 28. Now when I get ready to combine my like terms, they're already lined up. I get 6x to the third power, 15x squared plus 8x squared is 23x squared. 21x plus 20x is 41x. And then bring down your plus 28, giving me my final answer of answer choice D, it looks like. Another example of finding the product of a binomial and a trinomial. It's just a lot of work, so let's go ahead and get started. 2x times 4x squared is 8x to the third power. 2x times a negative 5x is negative 10x squared. 2x times negative 10 is negative 20x. Now I'm going to distribute the negative 3 to all three terms. Negative 3 times 4x squared is negative 12x squared. Negative 3 times negative 5x is a positive 15x. And negative 3 times negative 10 is a positive 30. Now, I'll simply add or combine my like terms to simplify. I'm going to do it over here to the right. I'm going to bring down my 8x to the third power. And then when I combine negative 10x squared and a negative 12x squared, I get negative 22x squared. Negative 20x plus 15x is negative 5x. And then I just bring down this plus 30 into my answer, which gives me an answer choice of A, it looks like. Notice in this problem we have a shape, looks like a rectangle, and it says to find the area of the shape. Now don't get this confused with something that we did last chapter. Last chapter we found the perimeter of the shape, which is where you added up all four sides or all the sides of the shape. Area means something different. Area is asking for the amount of space within the shape, and generally speaking, area involves multiplication. So in this case, when asked to find the area, we're going to take our rectangle and recall that the formula for the area of a rectangle is the length times the width, and in some cases you might see it as the base times the height. Either way, in our particular situation, we're going to take our 7x plus 3 and multiply it by our other dimension, which is 5x plus 2. That's going to give us the area of this rectangle, and this should look familiar to what we've been working on so far. Let's take the 7x, distribute it to the 5x to get 35x squared. 7x times 2 is 14x. 3 times 5x is 15x. 3 times 2 is 6. We'll combine our like terms there in the middle to get 35x squared plus 29x plus 6 as the area of this rectangle, which is answer choice C, it appears. This problem asks us to find the difference of the products of two sets of binomials. So this problem is going to be a lot of work. Let's go ahead and get started. I'm going to start by simplifying this left multiplication part first by distributing this x to both terms. X times 2x is 2x squared. X times 7 is 7x. Now I'm going to distribute this 3. 3 times 2x is 6x. 3 times 7 is 21. So this left polynomial simplifies to 2x to the second plus 13x plus 21 after combining my like terms there in the middle. Now we got to move over here. We know that we're going to be subtracting our polynomials, and let's simplify this right one. X times x is x to the second power, which I'm going to write it above up here. X to the second power. X times negative 1 is negative 1x. 5 times x is 5x. And 5 times negative 1 is a negative 5. I'll come back and combine my like terms now to get x squared plus 4x minus 5. Now, this should look familiar from our last chapter where we added and subtracted polynomials. You may remember that on this right side, this right trinomial is in parentheses, and we have an understood -1 in front that we can distribute to drop the parentheses, in which case my result would be, I'm going to bring down this information from my left polynomial. I'll have 2x squared plus 13x plus 21. Then when I distribute this -1, I'll have -1x squared minus 4x plus 5. Now that I've taken care of that, it's just a matter of combining my like terms. In this case, 2x squared minus 1x squared would give me x squared. 13x minus 4x would give me 9x. And 21 plus 5 would give me 26, giving me my answer of B. Now what you may notice is that this one looks like considerably more work than the previous problems, but it's nothing new. It's just more steps. In the last example problem for this video, we're going to find the difference again of the product of two sets of binomials. Let's get started. On this left one, I'm going to distribute this 3x to the 2x, which would result in 6x squared. 3x times 1 is 3x. 4 times 2x is 8x. 4 times 1 is 4. We'll simplify this by combining the like terms to get a result of 6x squared plus 11x plus 4. We know we're going to be subtracting the right polynomial. Let's go ahead and get started distributing this one. X times x is x squared. X times 4 is 4x. -5 times x is -5x. -5 times 4 is -20. We'll combine our like terms there in the middle to give us x squared plus, x squared. 4x minus 5x combines to give you a -1x, and then bring down the -20. You may notice now from our previous problem and previous unit that there's an understood -1 in front of this right polynomial. The reason we didn't necessarily group the left polynomial is because it would be an understood 1 anyway that wouldn't change anything. Let's go ahead and take care of this right, or simplify this polynomial farther so that we can get our answer. So I'll bring down the 6x squared plus 11x plus 4. And now I'll begin distributing this -1 to get -1x squared. -1 times -1x is a positive 1x. -1 times that -20 is a positive 20. And now we'll combine our like terms. 6x squared minus 1x squared is 5x squared. Positive 11x plus 1x is 12x. And then we'll take our 4, combine it with our 20 to get 24, giving me an answer choice of A. All right, hope this video was helpful. Thank you for watching.